Well, hey everybody, welcome to another episode of Master the NEC, where we talk all things electrical about the National Electrical Code, and again, anything electrically related. My name's Paul Abernathy, your host, and if you've not been aware of our podcasts, what's wrong with you? We're all syndicated on things like Spotify, iTunes, iHeart, even Amazon now. You can get our shows just about everywhere. In fact, you can even go on YouTube and you can watch our videos, or you can listen to all of our podcasts as well. In fact, whether it's a video or a podcast, we will actually tell you in the thumbnail now so you know whether or not you're going to get a video or you're going to get a podcast. So again, that's over on youtube.com/Master the NEC, all one word. All right, so welcome to today's show. We are going to talk about something that every now and then I get some questions about, and it changed a little bit in the last 2-3 cycles, really more just moving it around. So we want to talk about it today. So again, I'm building the suspense. Hopefully you'll hang in there with us, but it is a pretty important topic that is going to apply to single phase dwelling services and feeders. And it is something that people ask me all the time. When can I apply it? When I can apply it? And what does it mean when I'm on an exam? And how should I take this versus real life? So we're going to talk about that. But first, we have to have a word from our sponsor. So let's run this important commercial, and then we will get into today's topic. Today's show is sponsored by electricianpride.com, your one-stop shop for electrician-specific t-shirts, hoodies, phone cases, mugs, die-cut stickers, leggings, and so much more. Featuring unique designs for electricians, journeymen, and master electricians, as well as electrical engineers and electrical inspectors. For more information on all the products that are available, visit us at www.electricianpride.com today. All right, so if you're in the market for Tesla shirts, Master the NEC shirts, or Master Electrician, Journeyman Electrician, Engineer, Electrical Inspector, we got a neat designs over there, so go to electricianpride.com. Again, great stuff. Even got masks, COVID-19 masks and gaiters and all that kind of stuff. A lot of stickers. Go check it out. There's a lot of stuff there. Again, we appreciate everything you do to help us along the way. All right, so today, if you haven't guessed it by now, what is our topic going to be? And should I build suspense? That's good enough. We're going to talk about 310.12, which previously was 310.15b7, and before that it was 310.15b6. So we just covered a whole spectrum of code cycles where that's kind of changed a little bit. And this has to do with sizing the conductors for a service or feeder based on the service or feeder rating. So this is a permissive allowance for sizing these conductors. But there's rules that have to be met with it as well. So we have to look at the rules to get a firm understanding of it. But again, this is all permissive. It's not an exception. It's permissive. Means that if I wanted to size conductors based on the size or the rating of the service disconnect or the feeder disconnect, yes. Okay? Their rating, I could. We size that based on 240.6a. We go pick a standard ampere rating, whether it's for fuses or inverse time circuit breakers. That's the rating we use, and we could size our conductors accordingly. And of course, we always have to be able to size them to handle the load that we're anticipating, that we're dealing with based on a load calculation under Article 220. However, we do have some permissive rules that allow us to size conductors smaller than it would be sizing it based on whatever the rating is of those devices. So that's today's episode. We're going to really get into that. And we're going to demystify it. We're going to make it clear because I do get people that ask me about it. Okay, so let's get this one out of the way real quick for exam people. For those that are preparing for an exam, you always want to answer it to the best possible answer. Since this is not an exception, there's usually a statement on exams that say do this unless exceptions don't apply, unless they make a reference to it. This isn't an exception. This is a permissive allowance in the NEC. And so for exams, they want you to resolve it down to the best possible answer. So this would be the best possible answer, as long as it falls within the parameters of 310.12a or b when it comes to sizing. Okay, so we're going to look at all that again. So we're going to make it really clear. Now, so that's exams. Always solve it down. In real life, you can do what you want. If you want everything to be full-size conductors based on the rating of the devices, that's fine. You have that allowance to do that. This is permissive. But most people will take advantage of this if they realize that the service or the feeder system that they're dealing with allows them to be within the parameters of 310.12, then most people are going to do that. Okay? Most are going to jump for that opportunity. So let's kind of look at 310.12. So I'm in the 2020 edition of the National Electrical Code, so that you kind of have a foundation of what we're working out of. If you're in the 2017, no big difference here. It's 310.15b7, so you have no excuse not to crack that code book open and follow along, okay? All right, so I'm going to read it to you, and then we'll explain it. 310.12, it says single phase, so it's very much driven by a single phase application. It says single phase dwelling services and feeders. It says for one family dwellings and the individual dwelling units of two family and multifamily dwellings, service and feeder conductors. So that's what we're talking about here. Okay. Nothing to do with the load calculation that took place in 220 in order to determine what size service or what size feeder breaker we needed. It's not about that. That's already been determined. We're doing service conductors or feeder conductor sizing. Okay. So it says service and feeder conductors supplied by a single phase 120/240 volt system shall be permitted to be sized in accordance with 310.12 A through D. So we have an A, a B, a C, and a D. Okay, so if it's a 120/240 volt service, single phase, then I've got A, B, C, and D. Allows me to apply these rules, and then I can, again, it's going to result in smaller conductors. Okay. Now, it goes on to say, for one family dwellings and the individual dwelling units of two family and multifamily dwellings, single phase feeders, okay, so this is feeder driven, single phase feeders, conductors consisting of two ungrounded conductors and neutral conductor from a 208Y120 volt system shall be permitted to be sized in accordance with 310.12 A through C. So if it's a 120/240 volt system, then you can apply the rules of 310.12 A through D. If it is a 208Y120 system that's derived from a three-phase, obviously it derives from a three-phase, so now it's single phase being derived from it, then as long as it has two ungrounded conductors and a neutral conductor, then and it's 208Y120, then I can use 310.12 A through C, but I can't use D. D has to do with the reduction in size for the grounded conductor. Doesn't apply in an application where it's 208Y120 because of how it derives from the three-phase system. Okay, so again, for another theory class, but again, here's point blank telling you you're not going to use the option for the grounded conductor in D. Okay, when it comes to a 208Y120 application. So most of probably what we deal in for dwellings and individual dwelling unit, probably going to deal in a 120/240, but in a multifamily buildings, you very much might have a three-phase system coming to the building, and then it derives from it single phase that's running out to individual units that are 208Y120. And again, this rule applies when it comes to sizing, okay? Just not when it comes to the grounded conductor. Just want to make that clear, okay? All right, so let's look at it. So we have what's called an A, a B, a C, and a D. So we're going to focus on each one of these and kind of lay out when you can use it and when you can't, okay? Because that's the biggest question that I get from most people. So let's look at A, services. Here's what it says. For a service rated, and again, where do we get the rated? You look at the informational note at the bottom. There's an informational note number 1 that reminds you how we got that service rating, which again is based on the standard ampere rating of fuses or inverse time circuit breaker. That's your typical circuit breaker. All from 240.6a. That's where we usually go and pick that. Okay, so that's where you get your rating. Also applies to the feeder as well, just so we're all on the same page. It says for a service rating, 100 amperes through 400 amperes. So again, it's got to fall between 1 and 400 amperes is what our rating, our service rating has to fall in order for you to be able to use this rule. If it's above that, you're not going to use this rule. You're just going to size like you normally would, size your conductors like you normally would, and make sure they're protected by the overcurrent device, and you do everything you normally would do. All right, so this one says, For service rated 100 amperes through 400 amperes, the service conductors supplying the entire load associated with a one-family dwelling, or the service conductors supplying the entire load associated with an individual dwelling unit in a two-family or multifamily dwelling shall be permitted to have an ampacity not less than 83% of the service rating. And we know where we get the service rating. It's whatever the breaker is, okay? It says, if no adjustment or correction factors are required, Table 310.12 shall be permitted to be applied. Okay, so let's stop right here at the service situation and let's dissect a couple things in here. So there's a table here at the bottom, 310.12. Now this table was in Informative Annex D, and prior to that it was in the code, but it got pulled out. Now the reason it got pulled out is because people would go to this table, and if there was adjustment or corrections that had to take place, they would think that they don't need to be applied. You just pull the values from this table and you're just good to go. This is like a catch-all table. And so that wasn't correct. So if you still had a situation where you had to make a ambient temperature correction due to whatever the temperature was that you're putting these conductors in exposure to, then you needed to make a correction. And if you had over 3 current carrying conductors, then you still had to make an adjustment, okay, because of mutual heating. So the good news is the adjustments of more than 3 is usually not going to take place in these situations, okay? But you could have an ambient temperature correction that does come into play, and so that's going to be an example of what we use today when I show you how to do all this. So good news is if you have none of those conditions, there's no, the temperature is perfectly like it is at 310.16, which is 30 degrees Celsius, 86 degrees Fahrenheit. And you'd have not more than 3 current conductors in your installation, whether it's a feeder, and we're talking services right now, services or feeders, then guess what? If that's the case, then you've got no adjustment that you have to make for more than 3 current conductors. So that's fine. You can pull straight from this table and you'd be perfectly fine. Now, a couple things to bring out before we dissect A. Note this is a redundancy. Note the note. How about that? At the very bottom of Table 310.12, that note says, if no adjustment or correction factors are required, means they don't exist, this table shall be permitted to be applied. So that means I can pull straight from this table. Now, the moment that my installation is not 30 degrees Celsius, 86 degrees Fahrenheit, or the moment that I have more than 3 current conductors, this table is useless. Okay, this is why I tell people to learn to do the 83%. Okay, so if that's not the condition, you don't have adjustments or corrections, and you can pull sizing straight from this table, you're good to go for the service. Now, let's analyze A little more. You notice the part where it says that the service conductors supply the entire load associated. So what this means, let's talk about this. Service conductors supplying the entire load associated with the one family dwelling. Let's use this as an example. So I have a panel in this dwelling. Every one of the branch circuits, every one of the feeders has to come out of this panel. Okay? So that is an example of supplying the entire load. So those service conductors that are supplying that panel are supplying 100% of the loads. There's no upstream deviation from that, so that the service panel is not handling 100% of the loads. So again, and we'll look at an example for a feeder that's kind of very similar as well. But the key here is that in this application, service conductors have to supply the panel that it supplies 100, the entire load associated with the one family dwelling, for example. Or it just goes on to say, or the service conductors supplying the entire load associated with an individual dwelling unit in a two-family or multifamily dwelling. Again, it is still a situation where it has to handle the entire load. Okay, so assuming we do that and we do meet that rule, then we can apply the 83%. And that's going to tell me those service conductors have to be sized in amperage, at least 83% of the rating of the service. And so if it's a 200 amp service, let's just do a real quick example and we'll tie these things at the end. So it's a 200 amp service, and let's say nothing else exists that we'd have an adjustment or correction, and people were really screaming for this table to come back. And I'm like, why? I guess it's speed, but I mean, again, you just got to pull out the calculator. So it's 200 times 83%, 166 amps, right? So in this case, it's 166 amps. So what I would turn, if I wasn't using the table, and I would turn to 100, what I would turn is 310/16. And so in this case, it's a 200 amps. So I would go to 310/16, and I need a conductor that's good for 166 amps. Now, of course, we're going to be firmly in 75 degree because we didn't say anything. We didn't have any adjustment or corrections. So we're not using the 90 for adjustment and corrections. We know that we can't use 90 degree insulation anyway unless everything was rated at 90. So we're going to be following 110.14c. And I'm going to show you in a minute how that might be different if we're doing adjustment or correction based on the rating of the conductors that are in something like an SEU or an SER. But just follow with me. Since we're not making any adjustment and corrections, then we have to have a conductor that is at least 83%. At least 83% of the rating of the service, which is 200 amps. So if you go to 310.16, you go to 75 degree column, you scroll down, and you'll see that, 150 1-aught's not going to work. It has to be at least 166 amps. So you go to 2-aught, which says it'd be a 175. So there's your answer. So you would think it should be 2-aught. So when you go to the table 310.12 to correlate this, you go down to a 200, and you go over and you see that it's exactly 2-aught. And there you go. So that's how this table, because there is no adjustment and correction to take place, right? There isn't any. So it's pretty straightforward, the 83% rule. Now, let's talk a little bit about the adjustment and corrections and issues. So I can probably tell you that majority of the people around know what adjustment factors are when you got more than 3 current conductors. Although in this situation, I don't typically, because of how circuits are run, I don't see where you're going to have, more than 3 current conductors in this scenario. Okay. Now, again, you could have a bundling situation when you're running a bunch of feeders out or something like that. But in general, let's talk one family dwelling. I can't see where you're going to have to worry about more than 3 current conductors. So 310.15c1, probably not going to come into play. Can't say never, but probably not in this situation based on the parameters of 310.12. It's probably not going to come into play. However, you do have to worry about 310.15b1 because that's dealing with the ambient temperature correction factor. Now, I know this is going to be taboo, okay? And I'll ask the community out there. Here's what I'll do. How many of you electricians out there, when you run wire, well, I shouldn't say wire, when you run cable, I guess you could say wire, in a raceway, in an attic, do you adjust the ampacity for ambient temperature correction factors? Yeah, that's kind of what I thought. Chances are most of you do not. And again, those that do, okay, kudos to you. Because it means that you know how to work the parameters within 310.15b1, and you know when ambient has to apply and when it doesn't. Okay, so most people don't. Now, let's talk about the service conductors that are coming out from the meter, and they're going to hit the service disconnect and everything, and the overcurrent protected device, all that outside, right? Most times people do not apply an ambient temperature correction, even though the conditions obviously could be hotter than 30 degrees C or 86 degrees Fahrenheit. They typically don't. Now, rooftop applications, we harp all over that, but do you do it anywhere else? Probably not. How many of you really done it? How many services have you done and you really thought about the heat that's going to be blaring down on it because it's facing the southern sky 7 hours of the day? Probably nobody. Okay? I'm just saying. All right. So, but we have to do two things here. We have to separate fact from what would happen in the real world versus what you might get on an electrical exam. On an electrical exam, reality is out the window. They can throw in there that it has a certain number of current carrying conductors, which really would be hard to do based on what we're working with. But they could do it with a feeder application and tell you there's a number of feeders and blah, 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 and there's the bundling and all this kind of stuff. Or they could give you more or less an ambient correction based on what they're going to tell you is the ambient temperature at the location where this SCU might be, for example. And you have to know that you're going to have to do something, okay? So in our example today, we're obviously going to throw in the fact that we have a cable that's in 104 degrees Fahrenheit. Now, you might say, well, who tells me the temperature? Well, your inspector will. Otherwise, they probably don't know either, so that's why people probably don't do it. But there are documents. ASHRAE has values out there. There are different types of documents, historical data for the area, temperatures, maximums, things like that could be used. I'm not here to harp on it. I'm just telling you it's reality. The code says what it says. Now, do many people apply certain things of the code? No. And things continue to work and everybody's happy and everything's fine. But I'm just making you aware that the code does make statements and there's no exception to that rule. So in this case, we are going to say we have an exam question. And we're going to say that they've stated that this SCU is being placed in a condition with 104 degrees Fahrenheit. And in that case, on an exam, we absolutely know we're going to have to do a correction. Okay, we just know that right off the bat. Okay, now if there's no correction and no adjustments, which is probably what people go for anyway, pull right from this table. Okay, all right, so that's kind of A. And again, the key here is got to be between 1 and 400 amps, service conductors, and it's handle the entire load. Okay, it's coming out of the panel that's being supplied by these service conductors. Okay, that's A. Now let's look at B. And I'll give you a scenario here. Now, B is dealing with feeders. Now, feeders, it says, for a feeder rated 100 amperes through 400 amperes, so it's still the same caveat, still same thing, says the feeder conductor supplying the entire load, so you've got that rule again, associated with a one-family dwelling, or the feeder conductor supplying the entire load associated with an individual dwelling unit in a two-family or multifamily dwelling shall be permitted to have an ampacity not less than 83% of the feeder's rating. And again, if you want to know what the feeder rating means, go down and look at the informational note number 1, and you realize it's based on the device that you're going to be selecting in 240.6a, based on load calculations that you did in Article 220. Okay, so 83% of that rating. So let's talk about, because we can use the same 200 amp and it would still apply. But let's kind of look at an example for the feeder. So let's redo this scenario with my one-family dwelling. So let's just say I'm trying to meet the rules of the NEC, and outside I've got my meter, and then I hit right next to it an individual SUSI-rated disconnection means that also qualifies as a service disconnect, but it also will qualify as my emergency disconnect. So let's just say I've got one, it meets all the rules. So obviously now when I leave that, it becomes feeders. And the feeder is going to go to my panel that's located remotely, maybe somewhere in the middle of the dwelling. Because we can't run service conductors through the property unprotected, right? 230.70A1. So we now have a feeder running through. So let's apply this rule here in 310.12b. So if that disconnect outside is simply the disconnect, and now it's actually feeding the feeder that's going to the panel that's located downstream, then we have to make sure that those conductors are what? That those conductors are rated at least 83% of the feeder's rating. Okay? So let's kind of read this rule and we'll kind of break it down. It says, for a feeder rated 100 amperes through 400 amperes, the feeder conductors supplying the entire load associated with a one-family dwelling, or the feeder conductor supplying the entire load associated with an individual dwelling unit in a two-family or multifamily dwelling, shall be permitted to have an ampacity not less than 83% of the feeder's rating. Now, if no adjustment or correction factors are required, Table 310.12 shall be permitted to be applied. Now, let's do the scenario I just gave you. So in that case, the 200 amp service outside is going to be feeding a 200 amp service inside. So again, the rating is 200 amps, okay? And so we would also be able to apply that rule for the service conductors coming down to the service disconnect under 310.12a. And then from the load side of that service disconnect is feeder that is going out to the feeder panel, okay? And again, that might be a main lug only panel because you do have the service disconnect outside. So in any way, it's still 200 amps. So I'm going to apply it. So my feeder conductors couldn't be less than the same as we did before, no less than 166 amps. Now, something else that's interesting is if I change that up and I were to put a panel outside as my service disconnect, and maybe it's only like a 4-circuit panel because maybe in my installation I've got 2 air conditioning units out there, and I'm thinking, man, I don't want to go from the panel inside and have to go back out and feed those air conditioning units. I'm right there. So I'll put in a service panel with a limited number of devices. And while I'm there, I'll just pop out of that and I'll feed those 2 air conditioning units outside. And then I will continue on and feed my panel inside where a majority of my actual branch circuits and things like that will be supplied from. Okay? So that's the scenario I'm painting. So in that case, the feeder that's going to the panel inside is not handling the entire load that's associated with that dwelling. It's not handling it. And if that's the case, then I cannot apply 310.12 to sizing of that feeder. I would have to size it based on the load that I calculate for that panel. And it would be, since in this case, if it was whatever it's feeding it downstream, I'd have to do a load calculation for that panel and size the conductor accordingly. And then I would be 310.16 for the ampacity values. So you have to meet the rules. Because I had a panel up front that loads came out of it, and then the feeder went on to feed the panel inside of the dwelling, I am not supplying the entire load from the panel that's inside the dwelling. And if that's the case, you cannot use the allowance of 310.12b. Everything would just have to be sized, full size, based on the load, based on the ratings and everything. And again, that is the use of 310.16. The ability to be able to use 310.12 means I have to be able to follow all of the rules, okay? All of the rules here that are associated with it. And again, if you have, 83%, and it's the same thing for 200 amp panel, it was 166 amps was the minimum, okay? And that's what led us to say, well, if we don't have any adjustment or corrections, then we just go to table 310.12, okay? Now, let's move on before I give you a scenario where we would have an actual correction so that you can see how we do this. Let's go on and knock C out of the way, because C, when it comes to the feeder ampacity, does apply to both the 122 40-volt systems as well as the 208Y120 systems. Okay, it says C, feeder ampacity. It says, in no case shall a feeder for an individual dwelling unit be required to have an ampacity greater than that specified in 310.12a or b. So it doesn't have to be greater. And again, my example was if I'm going from an outside disconnect or, and I'm running it up to the interior panel, that feeder, you basically size the rule in 310.12b for feeder. And so it's basically telling you that feeder's ampacity does not have to be required to have an ampacity greater than what is specified in 310.12a or b, whichever is applicable. All right, so in our case, typically, the easy way to picture this is I have a 200 amp panel, whatever I size it at 83% for the service conductors that come in, and then I go from there to the panel inside. Then again, as long as I meet all the rules in 310.12b and that ultimate panel at the end handles 100% of the loads, then that feeder conductor is not required to be any larger than the actual calculation would have demanded in 310.12a or b. Okay, so makes sense to me. C is pretty straightforward. It applies broadly to both of applications of single phase, whether it's the 208Y120 single phase or it is the 120 240 volt single phase. Now let's look at D before we give any examples of a ambient correction. Now D says the grounded conductor. Now remember, this applies to 120 240 volt systems. It does not apply to 28Y120 systems, okay? Because again, it's three-phase and you're deriving single phase from that three-phase, so you're not making connection to all the ungrounded conductors, so you'll have a disproportional imbalance on the neutral. So again, reducing the size of the neutral is not advised, but it is okay under the 120 240 volt application. So here's what it says for D. It says grounded conductors. It says grounded conductors shall be permitted to be sized smaller than the ungrounded conductors if the requirements of 220.61 and 230.42 for service conductors, or the requirements for 215.2, which is feeders, and 220.61 for feeder conductors are met. And again, that's all dealing with neutral loads. There's some allowances in the installation that allows you to reduce it by a certain size. If it's over 200 amps of neutral load, then you can have a reduction to the remainder at 70%. There's different rules that you have to follow in 220.61. And again, you have to also follow the rules for sizing for the imbalanced load under 230.42 as well as 215.2 for the feeders. So provided you meet these rules, what it means is that I can have an SEU, for example, or an SER, where you will notice that the grounded conductor is smaller than the ungrounded hot conductors. And if you meet the rules here under a 122 40 volt single phase application, then you can have a reduced size grounded conductor. Now, this is very common in cable that you buy from manufacturers, whether it's an SEU or an SER, where typically you're going to have a grounded conductor that is slightly smaller than you would the ungrounded conductors. And it's okay. Again, as long as that neutral or grounded conductor, in this case, the general rule, grounded conductor, which may be a neutral, may not, as long as it's sized to handle the imbalanced load, first and foremost, then it's okay for it to be smaller. Now, again, does not apply to 208Y120 volt applications. Only 120 240 volts does D apply. All right, now, what's important is the next two things we're going to talk about. And that is right underneath D. It says where correction or adjustment factors are required by 310.15b or C, they shall be permitted to be applied to the ampacity associated with the temperature rating of the conductor. So what does that mean? Well, I might have an SE cable, service entrance cable. Of course, it could be raceway as well, but we'll just keep it simple. Let's have an SE cable where the inner conductors have a temperature rating of 90 degrees C, or they might have a 75 degrees C of the conductors, because this rule says the temperature rating of the conductors itself. All right. So this is not specific for cables. This could be for a raceway where you're pulling individual conductors in it as well, but they have a temperature rating. All right. And that temperature rating might be, if it's THHN, it's 90 degrees in a dry. THWN-2, 90 degrees wet or dry. Could be a THWN straight, and that is only 75 degrees wet. Okay. So you have to think about these things, but you got to know the temperature rating of the actual conductor to be able to do these adjustment and corrections accurately. All right, so let's kind of give a scenario here. Let's say that we're running a service entrance cable, and we're doing a 200 amp service, and so the service rating is 200 amps. We did the calculation, 220. Obviously we had our ampacity, our conductor was selected if we had done it the regular method. But now we want to say I have a 100 through 400 amp application for a single family dwelling. It's 200 amp service. I want to use the allowance of 310.12. But the only thing that's different is that the ambient temperature is 104 degrees Fahrenheit. which deviates from the values that are in 310.16, which is 30 degrees Celsius, 86 degrees Fahrenheit. So that tells me I'm going to have to do what? I'm going to have to make a correction into my ampacities. All right, so let's assume that's the situation. So the first thing we already know is it's rated 200 amperes. So we took that 200 amperes, and what did we do? We multiply that by 83%. So that's what the rules say. And we're using 310.12a right now because it's a service. So that's 166 amps. Okay? Now, 166 amps, I have to have a conductor. That is 83%. Okay? 83% of that 200 amp rated service rating. So I need a conductor. Now, again, if there was no correction, then I could simply go to table 310.12 and I'm done. But we have a correction, 104 degrees Fahrenheit. So what do we do? Now, the first thing that I always tell people to do is, since we're using the 90, and that's the rating of the insulation, we'll just assume that it's 90-degree rated insulation for this example. So I can use the 90-degree column of 310.15b1 in order to find what my correction value is, okay? And what is my percentage, which is dictated in there as a decimal percentage, a decimal value. So let's go, since we know it's 104 degrees, we're going to go to table 310.15b1. And since our insulation is 90-degree rated, we're going to go to the 90-degree column, and we're going to come down, and on the right, we're going to follow it all the way down until we get to the 104 degrees Fahrenheit, because that's in our question. So you follow it down, it looks like the actual value that we're going to use is 0.91. So you're going to write that down. Just write it down. All right. The next thing that we're going to do is we're going to go, okay, I need to take what? That 166, because again, that is the 83%. We can't be less than that. And I'm going to divide that by the 0.91. You remember that little trick? If you want to go up, you use division. If you want to go down, you use multiplication. Well, in this case, we're only going to use division because we want to go up and find out which column we need to be in under the 90 degree in order to pick a conductor. And then we'll validate that based on what we know as terminal limitations in 110.14c within the 75 degree. But we can pick from the 90. So let's do that. 166 divided by 0.91 is 182.4. So I need a conductor from the 90 degree column because, again, we use 90 degree rated insulation. So we get to pick from there, knowing that we still got terminal limitations, but we're just picking a conductor right now. Remember, if we didn't have adjustment of corrections, we just went straight to the limitations, and that was 75 degree column, and picked a conductor. And so we're going to do that as well, but we're going to quantify that we're okay. But because we use a 90 degree insulation rating, we get to start our adventure in the 90 degree column in 310.16. So we want to find a conductor that's good for 182.4. So go over to 310.16, go in the 90 degree column, and we're going to assume copper unless stated otherwise, always on an exam or, anywhere else, depending on what you're using. And I'm going to go to the 90 degree column, and I'm going to come down, and I need a conductor that's good for 182. Well, 1/0's not going to work because that's 170. 2/0's fine because it's 195. So I'm first going to say that 2/0 looks like my choice. Now I worry about terminal limitations, right? So I just want to make sure. So again, I can't exceed the value that's in the 75 degree column, but we're just using the 90 for the correction that we just did. So I'm going to go to the left under the 75 and say that, that 2/0 has 175 amp value. Okay, so it's perfectly fine for a 166 amp rated conductor. I mean, that's what we calculated, right? That was the 83%. It had to be at least 166. So at the end of the day, under 75 degrees C, it's still good for 175. But because we use the insulation at 90, we were able to start at the 195 under the 90 degrees C. And so we look at it and we go, either way, a 2/0 is perfectly fine for this application. Okay, so what we're doing is we're going to choose a 2/0. Now, here's what's interesting. This was only one correction. And that was just for 104 degrees. If you'll notice, you go back to look at table 310.12, for the 200 amp, it still says 2 watt. You didn't have a significant change. So in the real world, the reason most people don't probably worry too much about it is because when they look at it, the temperatures don't change it that much to where it becomes a problem that would bump you out of that. So as an exercise for kicks and giggles, we'll go and pick a different temperature. Let's pick 113 degrees Fahrenheit. Okay, let's pick that and see what we got here. All right, so that would be 113 degrees Fahrenheit, let's say 45 degrees Celsius. And we'll look at it, and that multiplier is 0.87. So let's do the same thing we did before. Let's just see. 166 divided by 0.87. 190.8. So I need a conductor that's good for 190.8. So I'm going to go over here, and I want to jump into, again, the 310.16, 90-degree column. Let's drop it down. And it looks like, well, that 2 out is still good for 195, which means that, again, under the 75, under the 75-degree column, that 175 is still good, remember? Because remember what our actual minimum of 83% had to be? 166. So we're still good. Everything's fine. But now we're still in the 2 out. Nothing changed. So let's do a different one. Let's do it again. Let's make it hotter. Let's go to 122 degrees Fahrenheit. And it's, let's see, that's also, what is that? That's 50 degrees Celsius. So let's go to 122. Let's do it. So that multiplier is 0.82. So let's do 166 divided by 0.82. 202.4. All right. Well, when we come over to the 90-degree column and then we come down now, we see a problem because that 2 aught was good for 195. And, of course, at this point, we need one that's good for at least 202. Okay? So in this case, we'd have to jump up to a 3 aught. So that's where your temperature, again, 2 more temperature jumps on the scale on 31015B1 will put you into the next conductor size. So as you can see, it's pretty simple to use the 310.12. I hope people understand the 83% was what this table was derived based on historically. And whether this table's in there or not, just remember that this table is not a catch-all. If there's any correction or adjustment that has to take place, then you don't use this table. Then you're going to use the sizing rules that you would normally and size it for the Ampacity's 31016, and you don't get the break on the service and feeder conductor sizing. Okay? Just remember that. All right? So hopefully you got something out of this episode. I was trying to make it as clear as possible, but if I didn't and I confused you, I apologize in advance. It's pretty hard to do that in a podcast, but at the end of the day, hopefully you got something out of it. Until next time, folks, stay safe. God bless.